Alright guys, today we're doing 8.11 and it's our line of best fit notes. It's our last lesson of Unit 8 and today we'll be looking at using our calculator to find a line of best fit to model some exponential data. Okay, so we'll use our calculator to do this, so you have to have your graphing calculator. This uses some stats features on it, so you'll need to get that out if you don't have it out already. This box here on your notes is a good reference to look back on, but we're not going to read each step right now. We'll go through the steps as we do some examples. The only one we have to do together here first is step number 1, and we only need to do this step once. So as long as you set this on your calculator today, you won't have to worry about it anymore. If you borrow a calculator or use somebody else's, you might want to make sure you do this. It just sets up the calculator to be able to do the stats features we're going to use in a moment. So we'll go through these steps here. It's kind of weird what we have to do. We have to turn on the diagnostic. Okay, so to do that, we're going to click Second Catalog. Now the Catalog button is actually where 0 is. So if you look at 0 on your calculator, you can see the word Catalog printed. So to get there, we're going to click Second, 0. So it's our catalog, and we're looking for the diagnostics. So we want to jump down to the letter D here just so we don't have to scroll through each letter. The A means it's already in alpha mode, so you just need to click the D letter down here. Jump down to these. And now we're going to just scroll down to get diagnostic on. So we want to turn it on. So when you have diagnostic on highlighted, you'll click enter, and then enter again, and now you're done. Okay, so we only have to do that once. We don't have to worry about it. As long as you're not borrowing other people's calculators, it should be fine. Okay. The rest of these steps we'll go through as we look at some examples here of how to type in some data into our calculator to model it using an exponential function. Okay, to basically figuring out, well, what equation could produce these types of values. So let's just look at an example to start. We're not starting with any real-world context yet. We'll get to that in a moment. These are just random tables of data, and we'll use our calculator to write an exponential model. Okay. So to do that, we want to go to our stat feature in our calculator. So the stat button is right here. So we'll click the stat button, and then we want to edit some lists. Okay, so we're going to just click enter. So we're on the big edit, and we'll edit lists. So I already have some data on my calculator. I need to get rid of that. So to get rid of the data, I'm going to go scroll all the way to the top. So the L2 is highlighted. I'm going to click clear. I'm not going to click delete. You just click clear and then enter, and it gets rid of the data. Scroll to the left, scroll all the way up, click clear, then enter. You don't want to click delete because it will delete the list entirely. You just want to clear out the data. And then I'm going to type in this data into L1 and L2 in my calculator. So for X, I'll type X into L1, and then type Y into L2. So I'll type in 1, then click enter, 2, 3, 4, 5, 6, 7, 8. I'm going to scroll to the right, type in L2, so 14, 28, 56, 112, 224, 448, 896, and 1792. You want to double check at the end that your last two numbers are lined up so that you know you didn't miss any in either column. Okay, so now we're on step 3 from this box up here. So we want to do some calculations with this data. Okay, so we're going to click stat again. Oops, stat. So click stat here to get to this screen. We want to go over to calc so we can calculate. We want to click option 0. So we're going to type in 0 because it'll just basically jump down there so we don't have to click the scroll a bunch of times. So click 0. This is EXPREG. This means exponential regression. That's what we're calculating, a regression. It's the same way of saying like an exponential model. So we're going to click enter. And now it's giving us our regression. If you have a newer calculator, it might ask you for some other prompts or show you some other screens. Just basically keep clicking enter. You might have to click it like 3 or 4 times until you get to a screen similar to this one. it's not going to give you the equation right out. It's giving you like the template of the equation and then what each variable is. We really only care about a and b for the time being. We're not worried too much about r squared and r. These are more specific to statistics. We don't need them at the moment. So for a and b, we're going to plug them into the a and b spot in our model. The little caret here means x is our exponent. So to write my model out, I'm going to write y equals a is 7. I'm going to use parentheses to show that multiplication. So b is 2 to the x power. You should always have a variable in the exponent here. So y equals 7 times 2 to the x would give you this data set. Typically the numbers aren't as nice as this one, but this is a good way to start. When we see some real world problems, we have some ugly decimals here because that's just how real life works. So I want you guys to pause the video for a moment, see if you can go back and type in the data set for part B and calculate the model. Just a reminder, click Stat, go to Edit, click Enter on Edit, clear out these lists first, so go up all the way to the top, click Clear, Enter, Clear on L1, Enter. Okay, so pause the video, type in the data, and see if you can figure out how to do the model. Look back at the steps at the top to help you. Okay, so here's my model for the second data set, 9.715 times 1.550 raised to the x power. All right, let's look at example 2 on the back. So now we'll apply some actual context to this data set and see if we can use our model to answer some further questions and make some predictions. So here it says you've just created your own website. You're keeping track of the number of hits. So hits means how many times somebody's visited or anybody's visited the site. And you're keeping track in the table here over the first 10 months. So number of hits is our y variable. So maybe we write it here so we remember. And months is our x variable. So the first thing I want you to do is, just like we did before, use your calculator to type in this data set into L1 and L2. You can type this guy in L1, L2, and get your model for this data set. Okay, so pause the video, do that part on your own. Okay, so here's my model. 12.104 times 1.798 to the x. Here's what my calculator looked like after I typed in the data and calculated the model. I rounded to this thousandths place. The more decimals you have, the more accurate you are, so thousandths is usually good for these types of problems. So let's look at the actual questions here. It says, according to your model, how many hits do you expect in the 12th month? So now we're extending beyond the table, and we're looking for predictions here of what we're expecting to happen. So we're going to use our model to calculate. It's asking about the 12th month and then the 34th month. These are our x variables, right? Months is x. So here x equals 12 and x equals 34. So these are pretty easy because all we have to do is plug in that x amount, that x value, and then type it into our calculator. Okay, so for the 12th month, we can do y equals 12.104 to the 1.798, and then instead of x, we'll put 12. So I'll clear that. So I just click the clear button. 12.104 times 1.798 to the 12th power equals. So in the 12th month, we can expect about 13,816.7 hits. Now, it doesn't really make sense to have a decimal amount for like a hit on a website. So maybe we'll say about 13,817. We'll round up there because of this decimal. And then we'll do the same thing for the 34th. So y equals 12.104 times 1.798. Now instead of x, we'll have 34. We'll type that into the calculator. So the 34th power So this time I got a huge number. So after 34 months, this is 5 billion. So 55690137703 hits. That's over 5 billion hits after 34 months. So we can see that it increases super fast when it's an exponential function. Now our next problem says, when will you reach 500,000 hits? So this time we know the value of the hits, so we know y, we don't know x. So we'll plug in 500,000 for y equals 12.104 times 1.798 to the x power. So again, we'll use our logs to solve this. I want to get the base with its exponent alone. So I'm going to start by dividing 12.104 on each side. When I do that, I get 41,308.658 equals 1.798 to the x. So I have the base and the exponent alone. So at this point I want to switch forms. So I'm going to write it as a log. The base is 1.798, so log of the base, 1.798, switch the other two pieces. So 41,308.658 equals x, equals the answer, or sorry, equals the exponent. I can type this log in my calculator using the change of base. Remember, the base goes on the bottom. So you'll type it into your calculator using your log button here. And when you do that, we get 18.117 for x. Remember, x is representing months, so we can say about 18 months. All right, guys, we have one more example we'll do together here. So this table is showing us some information about the number of cranes in Japan from 1950 to 1990. Cranes are a type of bird that lives in Japan, so we're looking at how many birds there are in this span of time. Okay, so the point of doing this problem is to understand how we represent time in a data set. So notice we started at the year 1950, but our first unit of time is 0. Okay, so this table is representing the years since 1950. We can't type like 1950, 1960, 1970 into our calculator. That doesn't make any sense. That doesn't work for the calculator. So what we need to do instead is count from a beginning point. So like this would be the year 1950. 5 years later, that's 1955. 5 years later, 1960, or 10 years after the starting. Right, so 40 years after we started, that's what gets us the 1990. So this unit here is how many years since the beginning year. Okay, and then the bottom here is our cranes. So just like last time, we'll start by typing in the information in our calculator and getting the model. You'll do that on your own. So we'll type L1 and L2. For L1, you're going to use 0, 5, 10, these numbers, not the actual years. Okay, so pause the video and type in that data on your own. Okay, here's my model for this data set, 250.310 times 1.104 to the x power. Again, more decimals gives you more accuracy when using a model like this. So part B is pretty similar to the problem we did above. Estimate the number of cranes in Japan in the year 2000 and 2020. Now this is a little different though, because this is telling you the actual year. So we need to go back to figure out, well, what number would actually go in our table? Meaning, how many years have passed since 1950? So if I do 2000 minus 1950, I get 50 years. 50 years have passed, so that's my x value. For 2020, I can do the same thing. 2020 minus 1950 equals 70. So when I plug in my x variable, it'll be 70, not 2020. You cannot plug in actual years. You have to use like time since the beginning. Okay, so pause the video here, plug each one in for your x variable, and calculate. Okay, so here are my two answers. After 50 years had passed, so year 2000, I had about 35,000 cranes. And after 70 years had passed, I get about 254,000 cranes. Okay, our last problem here to do together. Again, it's asking for a year, so what year, meaning we don't know that y variable, we don't know the output, but we know that there's 20,000 cranes, so we know the x input. We want to know. So what I'm going to do here is plug in the 20,000 in for y, I know the cranes, and I want to figure out the year. I don't know the x variable. Okay, so I'm going to plug in 20,000 equals 250.310 times 1.104 raised to the x power. Okay, what I want you to do is see if you can solve this equation. It's very similar to the steps we did above. So go back to the steps from before, see if you can solve that equation using logs. Okay, so here's my work and my final answer. So I switched to log form right here, typed that into my calculator. So I got about 44 years. Now that's not really answering the question because it says what year, not how many years have passed. So to actually answer the question, I want to go back to my starting year of 1950. We'll add those 44 years that have passed. So the year that we would have about 20,000 cranes would be 1994. Okay. So moving on to our last section here, these two problems I want you to try on your own. I just want to point out one thing about this first one. This is similar to the crane problem we just did. So it's giving you a bunch of population data since 1900. So when you type this in your calculator, you need to make sure that you type it in correctly. You cannot type in actual years into your calculator. So we're going to say that 1900 would be like year 0. So then this would be after 10 years, after 20 years, after 30 years from year 0, 40, 50, 60, 70, 80, 90, 100, and then 110. So this is what you're typing into L1. And then you'll type these numbers into L2. Okay, see if you can try both of these problems on your own. Pause the video, actually try them, and then come back to the video to check your answers. Alright, you guys, here are my final answers. So this is my answer for part A. Here's my model. For part B, just be careful. It's asking you about how many people we'd expect to live in the U.S. this year. So obviously it's 2020. So I did 2020 minus 1900 to figure out how many years have passed, 120 years for my x variable. Plug into the equation, use my calculator, for about 382.3 million people, because it's in terms of millions. And then below, I know the y variable, I'm solving for x, so I plug in my y, use logs to solve. So I got 136.8, so that's about 137 years. After 1900 would be year 2037. And then the second problem down here. Similarly, this is years since 1989, so it's very similar to the crane problem. And so you can check your answers here.